purpose of this video is to go over question 16 on 2.1, and this is very similar to question 15 on 2.1 that I did before, and you can find that video. So on this one, there's a few different methods to use in 2.1. 2.1 kind of introduces this by taking the limit as the secant line approaches the tangent line at some x0 point. They give you this equation. I prefer to kind of use this equation simply because it's very, very similar to what you'll do in 2.2 and 2.3. So setting up this problem with this equation, I'm going to plug in x0 plus h to the equation and minus f of x0. So you see here I plugged in x0 plus h in the equation, and I'm going to simplify that, and everything after the negative should be canceled with something before it. So if I distributed this negative, I would be able to cancel my x0 squareds. This negative distributed here would cancel with the 9x0 before it, and the negative 20 is going to cancel with the positive 20. So I should be only left with terms with an h in it, which is important because I should be able to factor out that h, or one of the h's. So you see here I have those three terms left. If I factor out an h, I would have 2x0 plus h plus 9 divided by h, but when I factor out the h, I'm able to cancel it with the h in the denominator, and I'm left with the limit as h goes to 0 of 2x0 plus h plus 9. Applying the limit, I get 2x0 plus 9. It's going to be very, very close to doing a problem like this by the definition of the derivative. So if I was to enter this, this would be 2x0 plus 9 as my answer at a general x0 point. And then using this equation for part B, I'm plugging in the value of x0. They're asking me, in this place, I plug in 5. So I have 2 times 5 plus 9, which gives me 19. If you have any other questions on this, please let me know.